So welcome to the Agriculture channel. So today we are going to discuss about some important concept which is related to water management. That is, one is duty and another is delta. So in this case, first of all we have to know some terms. First one is crop period. So if we will see what do you mean by crop period. So crop period is nothing but it says that duration in days. That means it will be expressed in days. So duration in days from sowing or planting to maturity. That means as we know that suppose mustard crop. So suppose mustard crop, the crop period will start from the sowing date. It will start from sowing to harvest. Or we can say maturity. This will be we are saying it is crop period. Okay. So first we are going for sowing, then it will take germination, then there will be some vegetative growth, then there will be some reproductive growth, and then there will be harvest. So from sowing to, basically we have to remember, from sowing to harvesting maturity, this called as from sowing to harvest. This is called as the crop period. Okay. Then the next term is base period. Base period, it is nothing but the duration in days. That means it is also expressed in days. Base period is also expressed in days. From first irrigation for preparatory cultivation to last irrigation, or we can say first irrigation if it is used for sowing purpose, to the last irrigation. As you know that in some of the crops, suppose in some of the crops like rice, so here we are going for puddling operation. That means you are going from preparatory cultivation. Before sowing of the rice seeds, or before sowing of before transplanting of the rice seedlings, you have to go for preparatory cultivation. And for this preparatory cultivation, what we need optimum soil moisture content. And for this you have to go for irrigation. So the thing is that either if there is any land preparation is there, so the first irrigation will be says that preparatory cultivation, and you know that what is the last irrigation. As we know that before harvesting of the, suppose this is mustard crop, and where the first irrigation is at the sowing time. Suppose it is mustard crop. Suppose now the crop is mustard, and the first irrigation is applied at the time of sowing. The first irrigation is at the time of sowing, because as you know that for germination purpose, imbibition is very much important. Imbibition is very much important process, which is the first process of germination. So this imbibition means absorption of the water by the seed. Absorption of the water by the seed. The seed will absorb the water, and this is called as the imbibition for the germination purpose. Okay. Hence, in this case, what we will see. So for mustard crop, the first irrigation will be applied at the sowing time, and as you know that the last irrigation will be applied just 10 to 12 days before maturity. So suppose this is harvesting maturity time. Suppose for this mustard crop it is, let us say it is 110 days. Suppose, for example, from sowing to harvest maturity, the crop duration will be 110 days. But as you know that we will stop the irrigation just prior to 10, we can say 10 to 12 days prior to the harvesting maturity. So that means here our first irrigation is applied. At the time of sowing, but the last irrigation will be applied. This will be the last irrigation. The last irrigation will be applied before the harvesting maturity. Okay. So the base period is nothing but the first irrigation to last irrigation. This is our base period. First irrigation to last irrigation. Whether the first irrigation will be applied at the time of preparatory cultivation or at the time of sowing, it depends upon the crop. Okay. Then next, coming to the most important that is point, that is the delta. So here the delta, and the delta means what? Delta means the depth of water required by a crop during its duration in the field. That means now you have the field. Suppose this is my field, this is my field, and the question is required by the crop, the depth of water required by the crop during its duration in the field. That means the duration in the field, what does it means? It means from sowing to harvesting maturity. Okay, so now what will happen at the time of sowing? Suppose this is the field and this is the crop. The crop will grow, it will mature, then now it will be harvested. So from sowing to harvesting, the crop will grow. And what is the total? As you know that from sowing to harvesting, you are applying water. What we are applying? We are applying water. So out of the total, suppose we are going for mustard crop, which is 110 days duration. So the question is, whenever this we are growing this mustard crop, what is the total depth of water required? What is the total depth of water required to grow this mustard crop? This is the thing. So if we will see, this is the field. So if we will see for easy understanding point of view, so you will understand this. Suppose we are applying this much of water throughout the crop period of the mustard. Okay, so the unit is mostly the unit we are expressed, it is in centimeter. That means that delta means the depth of water. Delta means the depth of water required by the crop, total depth of water required by the crop. Okay, so to which water would stand on the irrigated area if the total quantity of supplied has to stand above the surface without percolation or evaporation. Now the question is, so suppose a mustard crop is there, and which is 110 days difference. So now let's come to the question. Okay, suppose if a crop, in this case the question is, suppose if a crop of 100 days is irrigated at a 10 days interval, with 8 centimeter depth of water at each irrigation. That means each irrigation, how much depth of water is applying? We are applying 8 centimeter depth. So the crop duration is 100 days. If it is 100 days, that means how many times of irrigation you are applying? How many times irrigation is there? Obviously 100 days divided by interval means 10 days interval, so it will be 10 times. That means how many times we are going for irrigation? We are going for irrigation of 10 times, and each time we are applying 8 centimeter. That means the total depth will be 10 into 8 is equal to 80 centimeter. So now, so this is the mustard crop. Suppose in this is the same question. So this is the mustard crop. Okay, so if we will, the question is without percolation or evaporation. So the thing is that percolation means what? Percolation means whatever the water we are applying, if it will percolate downward, it means it will go downward. In this case, this is called as a percolation. Percolation means vertical movement of the water to the downward, and it is a loss. Evaporation means by means of sun heating effect of the sun, the water will evaporate into the atmosphere. So evaporation is a loss. Percolation, it will come to the by means of gravity, the water will go downward and it will join the groundwater table. It is a loss as it will go beyond the root zone. So the question is, if there is no percolation and no evaporation, then whatever the standing water is there, will be there. Suppose here we are applying 80 centimeters, standing water depth will be there just above the surface. If there is no percolation, and if there is no evaporation. Okay, so here the answer will be 80 centimeter. Okay, so now next coming to the duty of water. It is the second term, more important term here. What do you mean by duty of the term? Duty of water is the ratio between the area of crop irrigated and the quantity of water applied to the crop. Area means, so here you can see it is the ratio. That means here duty of water is equal to area divided by quantity of water, means it is nothing but the volume of water applied. So area of crop irrigated divided by volume water applied. So duty, so in this case, suppose this is my field, suppose this is the field and this is the length, as you can see, this is the length and this is the breadth. Okay, so this is my area, so this is my area, this is the area. So what is your area of cultivation divided by, or area of irrigation, is by this pipe, by this we can say the irrigation. Suppose in this irrigation pipe, so the water will come and it will irrigate the land. So we will calculate what is the volume of water, what is the volume of water discharged to irrigate this land. So now duty will be what is the area divided by the quantity of water or volume of water. Okay, so now we will say what is, if we will see the duty, though, and it is expressed in D as like delta is expressed. This is the delta, means depth of water, but the duty means area to be irrigated. We can say the area to be irrigated per cubic discharge running for a base period B. Okay, so if we will see, that means suppose I have 10 liter of water, suppose 1000 liter of water. The question is, out of this 1000 liter of water, how much of area I will irrigate? This is the thing, na? Per unit volume of water, how much of area you are going to irrigate. This is called as the duty of water. Okay, so delta means the depth of irrigation, whereas duty means the area of irrigation you are going for per unit quantity of water. Then next coming to the relation between duty and delta. So what is the relation? If the crop base period is B, and base period means first irrigation to last irrigation, 1 cubic water discharge is there. First of thing, 1 cubic means what? 1 cubic means 1 meter cube per second. This will be the discharge. That means within 1 second, how much of water will come? 1 meter cube water will come. This 1 meter cube means 1000 liter water will come. That means in this, suppose here in this pipe, the rate of discharge, suppose the rate of discharge is 1 cubic. Suppose the rate of discharge is 1 cubic. That means in 1 second, this pipe will discharge 1 meter cube of water, or we can say 1000 liter of water. 1 meter cube or 1000 liter of water. So now the question is, what the relation between duty and delta? Delta means depth of water, which is expressed in centimeter. So now the delta is equal to, if we were going for centimeter, then the answer will be 864B by D. Okay, and if the question will be asked in terms of meter, then the answer will be delta in case of meter, then it will be 8.64B divided by D. So how this relation we will get? So let us calculate the relation, or let us establish the relation. Okay, so as you know that what is the base period? The days or the base period is B days. So B dash means as units 1 second rate of discharge in terms of second. So let us first convert days to second. First convert the unit day to second. So B day 1 day means, as you know, 1 day means how many second? 1 day means 24 hour, means 24 into 1 hour means 60 minute is equal to 24 into 60 into 1 minute is equal to 60 second. So 1 day is equal to this much. So B day will be B into 24 into 60 into 60 second. So the base period, whatever the base period is there, so base period is B days, or we can say base period is, this will be 86400 second. Either we can say the base period is, we can say base period is B days, or base period is 86400 second. Okay, so as you know that, so let us erase this thing. So as you know that, what do we mean by delta? I have already told. Delta means what? Delta means what? Delta means the depth. Yes or no? Yes. So depth means, as you know that, what is the unit, what is the, how you will calculate the volume? Volume is equal to area into depth. Yes or no? That means delta, which is means the depth, is equal to, now it will get volume divided by area. Yes or no? And you know that here volume is, here what is our volume? Our volume is, in this second, suppose 1 second, 1 meter cube water is there. So here in 1 second, how much water is releasing? 1 meter cube water is releasing. That means in 1 second 1 meter cube. So how many seconds we have? So now the volume of water will be 86400 in 1 second 1 meter cube. So 86400 second means this much of volume will be there. Yes or no? No, yes sir. So now what will happen? Now the area is, here area is 1 hectare. So here in normal case we are taking area is 1 hectare, that means 10,000 meter square. Okay, so what is the delta? So what is the delta? So delta will be volume will be 86400 meter cube divided by area means that is the duty. Area, it is nothing but the duty. So in 1 hectare it is 10,000 meter square. If it is d hectare, that means it will be 10,000 d meter square. If it is 2 hectare, that means it will be 20,000 meter square. So d hectare means 10,000 d meter square. So here 10,000 d meter square. So it will be cancelled. Then now it will be 20 will be cancelled. So now it will be 20 in the denominator, 100 is there. So duty will be 8.64. So how many days? So B days is there. So this is B into so B into, so this is B into, so now 8.64 B divided by D in meter, the unit will be meter. So if the delta in terms of meter, it will be 8.64 B by D, and if you are converting into centimeter, then just multiply 100, so it will become 8.64 multiply 100, then it will be 864 B by D. Okay, so this is the most important thing you have to remember. So delta is equal to 8.64 B by D in terms of meter, or 864 B by D in terms of centimeter. Okay, then next coming to the question. So duty of crop is a crop of 120 days base period. So B is equal to 120, and what is the duty? Duty is already given. Duty is 864 hectare per cubic. Okay, that means area, as you know that area per unit volume. So what is the delta? As you know the delta is equal to, in terms of meter, then it will be 8.64 B divided by D. So here it will be 8.64, B means 120 divided by 864, and if you want to convert into centimeter, then it will become 8, just multiply in terms of centimeter 864 B by D. This will be in terms of meter. Okay, so 864 into 120 divided by 864. So now it will be cut, and now the last answer will be or 1.2 meter. So either 120 centimeter or 1.2 meter. So this is the most important question you have to remember. So now if we'll see factors affecting the duty of water. So you have to remember, very easy. Okay, don't panic, it is very easy. So duty means what? First of all, duty means what? Duty means area of irrigation per unit volume of water. Okay, so suppose that means water volume is constant. So in this case, suppose water volume is constant. Suppose I am applying 1000 liter of water. Okay, so now you say, so water amount is constant. So type of crop, suppose I am going for two crop, one is rice, suppose another is green gram. So as you know that in case of rice crop, it will demand more water demand. It will demand more water, but it will demand less water. So if it is less water demanding, that means with this liter of water, with this amount of water, I can irrigate a larger amount of area. Yes or no? As individual green gram will require as individual green gram plant require less amount of water, so I can apply more area. I can apply irrigation to the more area of cultivation. Okay, so now the duty will increase. So type of crop means the crop which will require less water, the duty will be more. But in this case, individual rice crop, it will demand more evaporation is there, more percolation is there in this case. So for individual rice crop, the demand is more. That means within this, what is the amount of water I have? I can only apply to less area. Okay, so if the crop will demand more water, then duty will be less, or the area of irrigation will be less. Okay, then obviously the next factor, that is climate and season. So climate, in under this condition, one is evaporation. As you know that evaporation means what? Evaporation means loss of water. Suppose in the two area, there is area 1, this is area 2. So this is area 1, the evaporation is high. High evaporation means whatever the water I have, that is 1000 liter of water, whatever the water I have, I am applying to this area, and suddenly it will be getting evaporated. So it is a loss. So though I have a constant amount of water, okay, and I am applying this water, but suddenly the water going for evaporation loss. That means with this amount of water, I can irrigate to a very less area, because more loss is there. But in this case, area 2, in this case, suppose less evaporation is there. That means loss of water will be less. It will decrease. That means within this this quantity of water, I can irrigate a large amount of area. Because loss of water is less. Okay. Then next is effective precipitation. So what do you mean by effective precipitation? Okay. So effective precipitation means what? Suppose this is my soil. And the crop is there, and as you know that precipitation means the rainfall. So effective precipitation means effective rainfall. Suppose the rainfall is there. As you know that some of the rainfall water will go runoff runoff loss, some of the rainfall water will getting evaporated, and some of the water will go downward beyond the root zone. Suppose this is the root zone layer. Suppose this is the root zone layer. Suppose this is the root zone layer, or we can say soil moisture. So most of the water will also go beyond the root zone. So this is the crop. So this is the crop, this is the root. Okay. So this is the root or rhizosphere zone. This is the, we can say, rhizosphere zone. So if the water will go after infiltration, suppose after infiltration the water will go downward. The water will go downward beyond the root zone. Now suppose the water will go downward beyond the root zone and it becomes unavailable. So this is called as the precipitation. Okay. Sorry, this is called as the percolation. So vertical movement of water beyond the root zone. This is called as the percolation. So whatever the remaining water, whatever the water remained within this root zone, whatever the rainfall water remained in this root zone after runoff loss, evaporation loss and depercolation loss, whatever the water remained in the within the rhizosphere zone, this is called as effective rainfall. Okay. So as you know that higher amount of effective rainfall means higher amount of water will be stored in the root zone. So if already the rainfall amount is stored in the root zone, can you say me whether the irrigation is needed or not? No. That means if more amount of effective rainfall will be there, that means the number of irrigation will be decreasing. So that means with this amount of water I can irrigate more amount of area. Are you getting my point? Okay, so higher the, so if already effective precipitation is there, effective rainfall is there, now the water is already present within the soil profile. So in order to grow this crop I require less irrigation. If I will require less irrigation, then what is the amount of water I have? So I can apply this water to a more number of area. Okay, so more the effective rainfall or precipitation, more will be the duty or more will be the area of irrigation. Then next, coming to nature of soil. So nature of soil. So this is the same concept, nature of soil. Suppose there is two types of soil are there. Okay, one is clay soil, another is sandy soil. As you know that clay soil means more amount of micropore is there, but sandy soil means more amount of macropores are there. So as in sandy soil more amount of macropore is there, so most of the water, whatever the irrigation water I am applying, so most of the water will go downward, which is called as percolation. So percolation loss is more in case of which soil? In case of sandy soil. So if percolation loss is more, that means very less amount of water is remaining. So very less amount of water is remaining within the rhizosphere zone to grow the crops. So percolation loss more means you have to apply more amount of water in order to grow the specific crop. You need more amount of water application as more loss is there. So that means whatever the water I have, that is 1000 liter. So with this 1000 liter of water I can irrigate very less area in case of sandy soil. But in case of clay soil, so there is no very less percolation. So in this case a less percolation is there. So the in case of micropore more, so the most of the water will store within this micropore. So now whatever the rhizosphere zone is there, the water will be stored here because of the more micropore content. Hence whatever the water I am applying, so now water will store here. There will be no loss or very minimum loss is there. So with this clay soil, if I have the clay soil and I have 1000 liter of water, then with this 1000 liter of water I can irrigate more amount of area. In case of clay soil, because loss is the percolation loss is very less. Okay, so duty of water will be more in case of clay soil as compared to sandy soil. Then next, coming to management factors. What are the management? Suppose I am going for tillage operation. So if we are going for tillage operation, then you are allowing the, you are allowing the soil, you are allowing the water to infiltrate into the soil, so it will affect the soil moisture. Okay, so the tillage practices which will decrease the percolation loss, which will decrease the evaporation loss. So in this case, the duty will be more. Another is leveling of the land, leveling of land. So as you know that if my land is labeled, another is my land is just not labeled. Suppose my land is not labeled, this is my land, it is not labeled. Okay, so whatever the rainfall is there, so there will be runoff loss will be more. So runoff loss will be more in this case. So runoff loss will be more, as you know that if there will be any loss of the irrigation water, then the duty will decrease. So here the duty will less if it is not labeled. Okay, so if it is labeled, then the duty will be more. So this is the concept behind the duty and delta, and I hope you have understood all the concepts behind this. And if there is any doubt, then please write in the comment section, and in the next chapter with respect to duty and delta, we will solve some most important questions which are frequently asked in different ICAR as well as